From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez.
I would argue right now, especially more historically than a couple years ago, but definitely now even still, the material science engineering discipline, if you will, in the scope of metal powder bed fusion they have a lot of power right now because we look at it from the holistic process of what are we trying to validate, what are we trying to control. It all comes back down to functionally welding principles, right? And how we define our system to control that is very critical to it.
That's John Laureto from Renishaw. John is an applications engineer at Renishaw's Additive Manufacturing Solutions Center. He joins me today to talk about the importance and difficulty in building a qualified process for metal 3D printing. Welcome to the podcast, John. So before we get started, why don't we just start with a little bit of an introduction and kind of how you ended up at Renishaw?
Sure, Mike. Yeah, thanks for having me. It's much appreciated. So, yeah, I've been doing metal additive for quite a few years now. I was fortunate enough to do some work with it in grad school when I was still going through that phase of my life, and then worked for a service bureau for a number of years. Got to run machines, manage quality processes, do powder development, process development. Eventually, that led all the way up into working for one of the OEMs that makes the equipment, right? So I found myself at Renishaw probably just about 3 years ago now. Originally onboarded in as a material science by background, a metals process application engineer, if you will. So I was always trying to help customers develop applications and projects and materials for what they're doing. And I've now just kind of progressed over into an application manager role and even to some of the operational side, trying to get involved with things like part numbers and stuff like that, right? All the glorious paperwork background side of it, right? But yeah, that's been what I've been doing.
And you have a materials science, kind of metallurgy, academic background, and kind of did you always have a pull for additive stuff, or when did that really start?
For certain, yeah. The initial pull in additive, it always starts with like the rep wrap style printer, if you will, in your graduate school laboratory, right? So that's really where my first initial interest came into the technology. So really, it's the FDM side. My curriculum I went to Michigan Tech, and the curriculum there is very metals heavy. It's called material science, but at the time I was going through it, it's one polymer class, right? So really, it's a metallurgy course or degree, right? So really, combine the two interfaces, if you will, between rep printers and metallurgy, and working in some of the open source enterprises there, and I really started to kind of dig into that and kind of get more interested throughout my career.
Yeah, and for me, I know when I was starting out, kind of similar pathway, like it didn't really click for me until you started getting in front of the machines, seeing the actual living material science in front of you. And as you just described, you've operated a whole host of machines and variety of platforms. So how important do you think it is to have that background of kind of, you have the materials background, but also on a day-to-day basis, you're seeing kind of up close and personal and throughout the time that you've been in the space, like printers operating, materials getting cycled through. So how important do you think that is in kind of living, breathing additive today?
Yeah, I think that scholastic endeavors, if you will, teach you the core process fundamentals. Moreover, they teach you how to understand and withdraw out critical variables from the process and try to analyze and interpret what's actually going on live, as you had alluded to, right? So, I would argue right now, especially more historically than a couple years ago, but definitely now even still, the material science engineering discipline, if you will, in the scope of metal powder bed fusion they have a lot of power right now because we look at it from the holistic process of what are we trying to validate, what are we trying to control. It all comes back down to functionally welding principles, right? And how we define our system to control that is very critical to us. So yeah, it's been invaluable, or very very valuable for my work going forward. I think it's gone a great strides for me, actually having a material science background in this industry, for certain.
Yeah. Yeah, and being at Renishaw too, I've had the good fortune of being out to your facility out near Chicago, and for any of those who have been there during AMUG or others have seen a very impressive site there. And one of the first things I learned about the company as a whole, I mean, I'd certainly been familiar with Renishaw, time in England and and seeing it across the industry, but the company as a whole, Additive is a component of many different parts, a many kind of diversified business where you're doing a lot of measurement, precision, and inspection tools for all sorts of manufacturing purposes. So, how does that kind of fit in with the additive side of things? I get the sense that there's a lot of emphasis on kind of machine reproducibility and part reproducibility. I struggle to say that today, but
Sure, sure.
in what you guys are doing.
Yeah, you hit the nail on the head, right? I mean, Renishaw it's a great workplace for an engineer to really nerd out, if you will. It's a manufacturing company down to its core. I mean, most of the company is engineers. There's very few, accountants and finance people. They exist, of course, right? But it's a big group of people, who really enjoy what they're doing and really care about what they're doing. But like you said, everything we do from a technology development perspective and R&D focus is all based upon metrology as a whole, right? So that's a very, very large topic, and what avenues you can leverage metrology come in all sorts and spans, right? So whether it's, like you say, using our laser interferometers to do one thing, or our touch trigger probes to do another thing, or machine tool calibration things, you can talk at length about that, right? What's interesting about that, though, is that we can then leverage those same manufacturing principles that we sell on to end users and actually use it to manufacture our own equipment as well. So that's one of the things that I find in the industry that's pretty unique about the Renishaw platform itself. And that, like anything, there's some subsystem componentry is obviously bought into that platform. But when it comes down to the optical control module, the PLC, the controller of our optical unit that controls where the lasers go in the build process bed, it's all designed by Renishaw, right? So we think about, process control not only from the sense of just manufacturing the melted component, the thing that we solidify out of powder metal, but also it goes full scale back up into the entire machine platform holistically, right? So, therefore, what the word that gets utilized a lot in our day-to-day operations here is that we're very vertically integrated in that sense, right? So there's a striving manufacturing disciplinary approach to that platform that's manufacturing the metallic component. And then finally, with the in-process metrology and any empirical data you're going to collect on that platform during the manufacturing process, right? And if you really split out, what portions of the additive process are you really going to try to concentrate on? I mean, it's never ending, unfortunately, right now, right? In the sense of there's so much. I had an old boss who always used to say, quality management systems are more or less, at the end of the day, recording and documenting what you say you record and document, right? Which is your quality process charts and KPI indicators for what you're doing for validation, verification of your process, right? So I think there's two different avenues to this conversation, really, is the machine side and then obviously the metallurgy side of the equation as well.
Right. And to that extent, like with customers and users and people you interact with on a daily basis, kind of how has the perspective on quality management changed over the last kind of 3 to 5 years? Has there been a shift in that conversation? Is there more emphasis on it?
Specifically to additive, I mean, for sure, I think the customer base as a whole is more or less starting to become more educated on the process and moreover what the process requirements are to be on their particular industry. So I'm sure you see this all the time too, Mike, in that you might, because I mean, being the OEM or you being in more the consultant area role, you get to talk to at some point, a guy in his garage, one day, and then one of the largest, aerospace companies in the whole world, right? In the same day, right? So
Right.
the breadth and distribution of conversations you're going to have with either of those guys is massively different. So, but in general, though, you do find that people are starting to. You love having those conversations where people are asking the difficult or tough questions, because at the end of the day, I think the end user customer base is going to help drive the OEMs to manufacture the component the component printer, in a way that benefits their quality processes, right? So things that they need to be able to control, we have to build the machine to accommodate for those requirements, right? So we definitely see in our sales process, if you will, for a machine platform, getting the capital good in there is just one bit of the process, right? There's a whole scope of architectural development to the manufacturing process that, Renishaw and I'm sure the other OEMs too have to help the customer develop to achieve confidence in the platform, because customer confidence in the platform enables more machine sales and therefore enables the technology to grow throughout the world at the end of the day, right? And that's where it comes full circle too, with the customers, the OEMs making the machines, and then the certification audit authorities as well, right? They're ramping up as well with what they're providing out there as guidelines, to give those, like I said earlier, the guys in the garage more confidence to buy one of these things and start doing something with it, right? Because they don't have millions of dollars to throw an R&D budget to validate a parameter set, if you will.
For sure. And I'm guessing in the types of conversations that you're having on the sales front, it certainly evolve with the number of people that are engaged, right? There's a different conversation you have with the engineers and the operators using it on a day-to-day basis versus someone on the engineering management side that has a vision for a center of excellence, or getting new machines in, or an order of a shop, a CNC shop that's trying to revitalize some of their offerings. So I think the types of conversations that we certainly have on that front is fascinating to see what level of understanding people have about the industry, the operation of machines, and kind of the level of detail and sophistication that you can go. Because, like you said, there's no real end to some of the quality stuff, especially with the different aspects of the process. It's not just the machine; it's other parts as well.
It's really interesting because, like, we're at Renishaw generally, we're very used to people talking about machine calibration, right, in the sense of linear or rotary axis stages, right? But we don't ever talk about that in additive right now. And I think it's because there's many other bigger fish in the pond to start going after, right? Um,
That's interesting.
and I laugh a little bit about it because we talk about how we have this, we have an encoder on our z-axis to control the linear displacement of the the build height functionally, right? So it's really important for that to be correct. But no one ever asks us to provide them with like a run out report for how well that platform moves. They just want to know what is the shrinkage factor across 350 millimeters, right? And I think that will happen in time. I mean, good luck selling a machine tool, not giving someone that information. You know what I mean?
Right.
So, right. So, and I think that'll happen in time, because at the end of the day, I think there's different ways to look at it, right? But they're, and I'll dig at our own technology a little bit, but in reality, it's a welding process, right? And the welding process is multi-axial in the sense of the galvos are moving up in the encoder bank or up in the optical bank, and then progressing down through a couple focusing lenses or conical lenses of some capacity, and going through a focusing coil through a protective window onto the bed, and then something's happening down there, right? And then the z-axis is moving down with displacement. It's going to have yaw, pitch, roll, and run out, right? So there's, I think in time, but the point is that in time those things will become more open for discussion. But right now, I think people are more concerned with, well, it's a different scope, right? Again, the guys want to know so we'll talk about the machine shop guys, right? They want to know hardness and density, and they're probably happy with that if they can pull a tensile bar at the end of the day, right? Where the aerospace guys want to know what the positional repeatability of Galvo X on laser 1 is across bed at this velocity, right? And therefore the conversations you're going to have with those guys are going to be completely different from one-on-one.
Yeah.
You know.
Right. And from where you sit and all the experience you've had, kind of if you put yourself on the other side of the kind of the customer side, what advice do you give people as they start to think about some of these questions? Because I mean, even for someone that's been in the space for a long time, it can be overwhelming to that you start to go down the amount of variables that are in each of the processes and each of the machines and each of kind of the workflows. Are there things you kind of end up focusing on and trying to build a premise around to help with your organization of thinking through kind of quality in the process?
I mean, you're completely right. If you say too much too early relative to a sales process, you're going to scare everyone away from it, right? So there's a measured approach that I think any OEM would be taking in how they deliver that solution to the customer, right? So being from Renishaw's perspective, we really consider it being more of a solutions provider, in the sense of here's a machine to go print stuff with it. Good luck, So in that sense, in that vein, what we try to do is educate the customers on we don't develop their quality management system for them, right? But we have a lot of, empirical data that we've collected on our own accord and or have our own anecdotal experiences on our platform relative to what they should be looking at from a quality process, right? So our intention is to obviously educate the customer to the point where they develop some form of consumer confidence in the machine, but also make it something that's uh, you know digestible, if you will, right? Let's take off the bit that you can chew and develop a business case around a very focused, highly engineered component geometry and get rocking and rolling in that regard. As new opportunities and markets open up, that's where you start to expand out and reach into something. I'm not a big fan of throwing someone a machine platform and saying good luck. It doesn't really benefit the industry or Renishaw directly, for that matter, right? It's really, we find the best that go into the market scope for the industry are ones that are done with a measured approach and allows the customer to get confident with that thing and really start running it, right. um,
Right, and
and
that's
that
what
gets
I
into a whole conversation. Go ahead, sorry. Yeah.
yeah, and I was just going to say that's what I've even seen at your solution centers there, and I mean you guys are partnered with I think ASTM facilities across the globe and universities, so you have kind of a platform of installs at a variety of places that you're interacting with folks on multiple different levels, right? It's not just kind of there's some kind of the really hardcore kind of aerospace approach, but also kind of everywhere in between, even for some of the newer users of the platforms.
For certain, right? I mean, and that's the thing too. The industry, I think, is still trying to figure out, it's what needs to be delivered to the consumer as a solution to help them validate component geometry. I think there's a well, when I let's take a step back. So when I say validate component, I think understanding how the machine platform architecture moves relative to, like I said earlier, z-axis movement, recorder speed and movement displacement, accuracies or inaccuracies, z height, repeatability, that type of thing. That's more stuff that I would argue is on the OEM side. I mean, meaning Renishaw's responsibility to improve that or maintain some form of repeatability on that platform. When it comes into weld integrity and process conditions and how you identify potential failure modes in that, I think right now the industry is more kind of sort of just figuring out what they want to do in that regard. So and for example, if you look at like a casting industry, right, there's simulation software to wazoo, right, on how a die cast is going to solidify at X volume rate, right. I mean, there's tons of data on that, and it's probably very well you know accepted and understood that it be fact at some point, right. And it's agreed upon in the industry because of standards, right. But at the end of the day, people are still going to be pulling tensile bars on castings, right, or taking chunks out of it to measure for shrinkage porosity in certain locations, if you will, right. So I think right now we're trying to figure out where does simulation meet up with the empirical data, because at the end of the day, I mean, everyone's still talking about getting a basis on stuff, right. So
Right.
or a basis, or we can hold some level of sigma across, a population data set, right? You know, it's kind of funny. I mean, you can hold 2 sigma anything if you make the bandwidth large enough, right? You know, it's not, and that's the balance of where is that bandwidth. We're not certain just yet.
Yeah, and just even thinking about it from a material science standpoint, there's so many different ways to characterize a part, right? I mean, a lot of the focus, at least I've seen, is the physical properties, density, tensile strength, modulus, things like that. But then you get into other applications where those are critical, like you don't want your parts to crumble, but at the same time, chemical resistance, long-term fatigue, other types of, of testing that, I mean, it exists in this space, but I would say it's um, few and far between. That like a general data sheet isn't necessarily going to hit every single material property known to man that would be applicable for a lot of applications. So I think
Right. I mean,
that, and it can't, right? Like that's not realistic. But
exactly. The data sheets, what I call those, like if you any OEMs or Renishaw's website will, here's 10 to 20 materials that you can start with, right? So I consider those more or less as market enablers for the end users, right? So again, that goes back to that earlier point of it helps develop solutions for a customer, which they can then learn the principles on a known or more known material that's been validated on the machine platform, and then allow those principles to transpire and allow them to progress onto more complicated materials. So like if someone's going to do aluminum, some type of, without saying nomenclatures, I guess, fancier aluminum than ALSA 10 mg is what I'll say. But they're going to probably start there, right? They're going to start with the bread and butter of metal additive as of right now, and then expand out into other avenues as the application drives it to that position, right? So right now, those data sheets are tensile yield elongation, reduction of area, density, and maybe a hardness test after some heat treatment to some AMS standard or something, right? And that's going to be where it is. I think in time we'll start to talk about fatigue a lot more. I mean, I think I hear that every time I talk to someone
yeah.
about, and it makes sense. It's an important thing, So some customers do like, well, we're going to ignore fatigue and just not ever do a rotary component with additive. Okay, well, that's one approach. That's fine. And others are like, nope, we got to have this whole thing qualified out to wazoo, before we even print a density bar with it, that kind of thing. So again, everyone has a slightly unique approach. No one's centralized in anything. And I think that's why there's not a lot of sharing in all circumstances as well, is because each guy who comes up with said standard is an internal standard that they think is their, what they know is their IP, because it's not something they can just go Google how to print metal additive correctly, that kind of thing.
Right. Yeah. It's a bit of a black art. And even, I mean, we've had long conversations, you and I, about kind of the documentation side of things. And that gets into all the steps that we do before getting into the machine, and what are you doing after for heat treatment and surface finishing that also has an impact on the part. So it's not the, there's so many different control points that um, can impact that final value, whatever you're looking for in the process.
For certain, right? I mean, you got to give these guys who've been doing this for 10, 15 years a lot of credit, because they're the ones who are originally down there twisting knobs, trying to get this stuff to work correctly. And has any of it written down? Probably not, but then they know how to do it though, right?
Yes, absolutely.
And that's great. You need those guys for certain. Every technology goes through that phase, of guys staying late in the office twisting knobs, sitting playing, watching it print for 5 hours. It's definitely a phase of the technology. But right now, like you say, it's starting to develop into, I think, where it has to go into more of it's manufacturing, right? It's a short run manufacturing program. There are some bespoke applications where it's large scale, but a lot of it is shorter production runs in comparison to the grand scheme of things, if you will, right? Not relative to additive, it does quite a bit, but manufacturing in general, it's a smaller subset for sure.
Right, right.
Yeah.
And kind of getting into kind of last few questions for the day. I'm curious. I mean, you can't talk to anyone for more than 15, 20 minutes about the state of affairs with COVID and everything. But how have you and Renishaw seen, if any, changes because of the pandemic, and perspectives on manufacturing and supply chain and 3D printing? Has that spawned any new conversations or new approaches in the last few months?
Quite a few, and I think the one we realized the most, and I think it's forced a lot of people to get a bit creative, right? So when these manufacturing facilities are on lockdown, if you will, and only offer in essential personnel, generally speaking, unless you're some form of like a lights out operation of some capacity, which do exist, there's always going to be those oddballs, right? But we have done lot of education to our end user customer base over the past couple months here about um, servicing and calibration of these machine platforms on their own accord. You know, right now the standard nomenclature for metal additive right now is is every 6 months or 12 months. A guy comes in to redo a scan field focus, power map, etc. Right on the machine platform to revalidate some machine condition, you hit go again, right? So we're finding that there's becoming a greater reliance on the customer base to understand really how these things work, the platforms, and then what we can do as a supplier to help them to educate them for one thing, but then also to enable them to do that themselves, right? So once again, once you force a customer to be in control of the quality processes, which includes machine calibration, they become better understanding of the technology and become process owners. And that's really where they can shine, because you can root cause things better, right? I mean, it's a classic engineering thing, right? You take stuff apart to figure out how it works, right? Well, if you know how that power mapping of the laser works, it gives you a better warm fuzzy, if you will, about it's going to shoot the right power every time you ask it to do that, right? Um, and so that's some of the stuff that we've noticed for certain, let alone inventory control and that type of thing, right? Which is some of the more obvious metrics of COVID, you know. But that's where we've seen a big impact on us.
Excellent. Well, I appreciate the discussion today, and hopefully we can do this again soon or on a regular basis as we get into different topics. And once again, appreciate the time.
No problem, Mike. Anytime. More than happy to talk.
Awesome. Thanks, John.
Good stuff.
All right. Stopping the recording now.